Hi, I'm Rohan.
Hi, my name is Srikrishna Sitaraman.
Today I'll be interviewing Sri Krishna, am I saying that right? Yeah, who's an electrical engineer and went to Georgia Tech. So I asked to start off, I'm going to ask you about your education and what your experience was like majoring in electrical and computer engineering.
Yes, thanks, Rohan, for the question. It's one that helps me reminisce back to my high school grad days. I studied my undergrad in electrical engineering in India. So back in high school, I kind of figured that I was more interested in electronics than in computers. So I picked a bachelor's of electrical engineering. And in India, the system is a bit different from here. There is more focus on um, textbook oriented and more focus on clearing the exams than uh, actually learning the concepts very clearly. So it depends on the undergrad college as well. So in my colleges, the colleges that were affiliated to the university, they were okay. Some teachers were really good. So one of them was that I liked was on RF and microwaves. So that helped me get a good grounding in electromagnetics, and that put my interest in RF. So that's why I picked RF towards my grad school as well. And when I applied for my master's and PhD, I got an admit into Georgia Tech. That's how I ended up there. I came into a research group that was doing microelectronics packaging, and I had no idea of what packaging was. I didn't have a preference much on like what field it's going to be on. My master's or PhD is going to be, but I because I didn't have an idea, I could pick anything and learn from that. So that's how I ended up at Georgia Tech, and in the group that was doing microelectronics packaging. And I spent the next 5 years there from 2010 to 2015, learning about packaging, the processes, and also doing RF design for the same.
Can you explain a little bit about what packaging is?
Yes. So microelectronics packaging, or what they call as packaging for short, is the process of essentially packaging the chips. This is the process that goes between the silicon chip being fabricated and the chip being mounted on a PCB. Because the silicon chip, once it's fabricated, it just has the silicon piece. It has the silicon and the active circuits in it, but it has no way of connecting to the PCB. So the packaging is a way of providing a way to connect the electrical connections, provide a housing for the silicon chip, provide mechanical stability, and also protect the chip from external factors like moisture, from large temperature fluctuations, and so on. So the packaging is more of a housing for the electronic chips. And this was a traditional view. And as the density of electronics grew in the last 20 or 30 years, packaging has grown from just being a housing for the chip to actually being a platform to integrate different components in the computer system or in any electronic system, integrating in a way to improve performance and reduce power consumption. So today's packages are being designed close to a scale of actual chip design, where the signals flowing through the package are very critical to the entire performance of the system. And they can integrate a processor, a memory, and some other components like capacitors and inductors all in one package, including in some cases antennas as well. So it's a holistic platform to integrate the entire electronic system.
Okay. Um, and you said that was what you were doing in both your master's and PhD.
Correct. The
Yeah.
master's was more of a coursework, uh, and there was no research specifically for the master's. So right when I joined Georgia Tech after my undergrad, the entire 5 years was spent in doing research and towards my PhD.
Uh, what was your first job or internship that you did during college?
Yeah, the first one was at Intel in Arizona, where I got an opportunity to work on signal integrity analysis for some of their mobile platforms. Signal integrity is analyzing the signal that flows through a package to make sure that it does not undergo a lot of loss or does not have a lot of noise from adjacent lines in the package. So that's the analysis is what is termed as signal integrity. And there are softwares to help do that. And the process for doing this starts off with getting a die, then you do the layout or the routing of the package. This is to specify how the copper traces will be on the package. And once we have the layout, then it goes into the simulation software, which then can help you analyze at, let's say you have a signal flowing at 3 gigabits per second, then you can analyze what's going to be the nature of signal, what is going to be the level of attenuation or signal degradation through the package, what's going to be the crosstalk if there are two lines right next to each other, what's going to be the impact of the signal in one line on the other line, and what's going to be the impact of power supply on the signal. All these analyses are included in signal integrity. So that's what I was working on at Intel in Arizona.
Um, and then moving on from that, your next job was at TE Connectivity.
Correct.
Mhm. And
So,
what'd you do there?
right. So that was an interesting turn I did not expect because right after my PhD, I got a job at TE Connectivity, and my initial project was, so the group I went into is corporate R&D group, which means they don't have products by themselves, but they help the other business units on their next generation products. So at TE Connectivity, I started off with building an RF module on a glass substrate. That was my first project. I spent about 5.5 years at TE Connectivity in total, but every, let's say 18 months or so, I had a new project. So I started off with this glass RF module project, but then the projects started going further and further away from packaging, but it was still very interesting. So I got to do some PCB design for wireless power, some NFC system for wireless monitoring of food that's being cooked in an oven. I also worked on some antenna designs, so all different technologies as the need arose. So I spent 5.5 years there, but it was not entirely related to my PhD. But I still enjoyed the work, so I continued there until I moved to applied materials for my next job, which was back to packaging and signal integrity analysis. So I was at applied materials for about a year and a half. And the couple of things I learned, it was a very nice job there, but a couple of things I realized was it's a good place to publish and learn, but because Applied Materials is a tool company that manufactures processes and tools for electronics, being an electrical design engineer, there is limited scope on what you can learn and grow. So that's the reason I moved to my current role at Marvell Semiconductors, where I'm focusing mostly on the latest electronics packaging, but more on the design part because Marvell is a chip manufacturing company and they make their own packages. It makes more sense for somebody like me to be at a role like that.
Oh, also, when you're talking about these packages, how big are we talking?
That's a very good question. And these packages, the size depends on the application. The smallest packages are what goes into, let's say, your Apple AirPods, because those are the kind of the smallest devices you can find. There are some medical devices which have even smaller chips and probably not a regular definition of a package. But let's say in popular terms, the AirPods are probably the smallest packages that you'll find. And then it also depends on what is the type of electronics inside the package. For example, if it's a RF device, it's going to be a very small package. If it's going to be a pressure sensor, it's going to be probably the smallest package you'll find. But if you're looking at let's say an AI system like NVIDIA's system, those packages can be as big as, let's say, 100 by 100 I believe. That's about one, yeah, 100 millimeters, about like 10 centimeters.
Yeah.
So they can be fairly big or really small, like 3 5 size.
And then so I guess from that, I guess I kind of get it. So like a bigger thing like an NVIDIA, like a graphics card or something, that's just one big package. It's not multiple packages within.
Yes, so it's a one big package, but it has multiple dies inside. There will be like a few processor dies, a few memory dies, and a few connectivity to a high-speed connectivity to outside world. So those kind of dies would be inside as well.
Mhm. And then right now, Marvel Technology, which kind of things you usually work on.
So currently I'm working on what we call as 2.5D packaging. It's a quirky term. You don't look for, like, you usually have like 2-dimension or 3-dimension, but in the world of packaging, we have something called a 2.5D, where there is something called an interposer. So we have a PCB that if you open up any computer, the first thing that you'll see is the big motherboard, or inside a phone, there's a motherboard. And that's what we call as the PCB, or the printed circuit board. Between the PCB and the silicon, there are a few levels of substrates. So in the traditional sense, the silicon chip would go directly on the PCB. That's called like 1D packaging, let's say, or 1D or 2D packaging. So 2D packaging means you have a package substrate, which is one level before the PCB. So the PCB has a limitation in the sense it can only form features that are large. Like in today's PCBs, they can form features like 100 microns, for example. 100 micrometers is the minimum width they can make. But there are requirements in some systems where you want to connect two chips at much smaller pitch because you have a lot more signals. So to enable that connection, you need a material that can support the smaller lines. So then that material is called a package substrate. A package substrate is like a more expensive PCB, let's say, a better quality PCB material. And that is the first level. Then you have what's called an interposer, which is even more higher quality, even more expensive substrate, but it can support even denser copper lines between chips. So designing systems where there are two dies connected on an interposer, that's what we call as a 2.5D.
Oh,
So that's what I'm working on at Marvel now. So it deals with understanding how the chips are placed on the interposer, what are the connections between the dies and connections to the outside world, and then doing the signal integrity analysis, how the signals are attenuated, how noise happens, how to mitigate noise, how to deliver power cleanly to the dies. These are all the aspects.
yeah. And then as you're researching, this is like the big end goal, trying to get these devices as small as you can so you pack more
Yeah. So on the chip side, the goal is there's a term called PPA, which stands for power, performance, and area. These are the three key parameters that they optimize for. So we want recently there came a report that said uh, the power consumed by all the data centers today, it exceeds a lot of the nation's power consumption. It's huge amount of power that's being used up by these data centers. And the way we can sustainably grow these data centers in the future is to keep our power consumption as low as possible. So power consumption is an extremely important part. Then there is performance, which is how many calculations can these processors make in a second. And then there's area, how big it is. So all these are uh, three different parameters or dimensions in which the silicon chip needs to be optimized, and therefore the package also needs to be optimized for these.
Mhm. Um, so I asked my last like big question is across all your jobs, were there any like specific things that you liked? I know you said at T connectivity, you said you worked on like a very large range of things. Uh,
Mhm.
do you prefer that, or I'm guessing you don't prefer that if you switch jobs, compared to doing something more specific?
All right, that's a interesting question. It's not. So there are a few things that I see as important in a job. One is, of course, a technical knowledge, like how much can you learn and grow. It's the second is how much can you get to apply what you learned. There are a couple of other things that are less tangible. So one of them is how much new technologies can you work on, and what part of it is like a research aspect. If you're just doing the same things over and over, or doing things that are proven, then there is no scope for exploring something. So that's one aspect. The other aspect is how are the people? That's one of the most important things, because even if your job is not that great, but if the people around you are amazing, I think that's a job that you want to stick to, because uh, at the end of the day, you're spending a significant amount of time in a job. Let's say you're spending like 8 hours a day at work or more. And the people that we interact with, if they have the right mindset, then it makes our life better. So these are the things. So my role at TE Connectivity was, I really liked it. The people were really good, and there were a lot of scope for doing new things. But the reason I had to move was that I wanted to go back to what I was doing, that is packaging. And because I had drifted so far away from packaging after the first year or so, it felt like I was just hopping on different projects. It gave me a nice exposure to different technologies, but it did not give me a good direction. So it gave me the breadth, but not the depth I wanted. So that's the reason I moved.
Uh,
But yeah, that's those are the things that I look for, and so far at Marvel, it ticks all the boxes. So let's see.
Also, speaking about like working with people 8 hours a day,
Mhm.
I know since COVID, a bunch of jobs in these areas have shifted online. Are you still
Yeah.
working in the office?
Yes, we go to office twice a week. In fact, there are some companies like Applied Materials, for example, they have mandated 5 days a week for all employees. So everybody goes into work all the time. For me at Marvel, we go in 2 days a week. And even then, working in person is one part, but when we are in meetings throughout the day, we still have to interact with our peers, and that makes a huge difference still.
Um, as right now, because you said that you're designing these, most of that are you doing on a computer with some CAD sort of website?
Right. Yeah, softwares that, yeah, we use. So CAD tools are used by what we term as layout engineers. They are people who design the physical routing, or what we call as the connections between the dies. But before that part and after that is where my role lies in. So before that, I work on, let's say there are two chips in a system. How are these two chips going to talk to each other? That's the first aspect. So there are, let's say, 150 connections up on one die, and 200 connections on the second die. Which of these pins should be connected together? Which of these pins should go to outside world? And which of these pins should power be delivered? So these are the kind of decisions that I have to take, or definitions that I have to provide. And based on that, the layout engineer will be designing the physical connections. Then I take the layout, which is done in CAD software, and we take that and do the analysis. So that is the next part, which deals with what we call as, yeah, what we call as the simulation software which do finite element analysis. So it's a way of analyzing how signals flow on the lines and how the crosstalk or the attenuation of the signals will happen.
Mhm. Um, yeah, so I guess my last question is kind of aside from all of your work and anything, what do you like to do outside of work?
That's a good question, because work-life balance is one of the things that I missed mentioning at the things that you look for in a job. So far in all the jobs that I've had, the balance has been pretty good. Outside of work, I do a few things. So of late, I've been starting to read more books because I realized I've completely lost touch with physical books or any books for that sort. So I read a lot of books. I also play the guitar, but more on the Indian, South Indian style. Uh, I also try to get some exercises or workouts done when I find time. But yeah, some of the key things that I do.
Yeah. Um, oh, also kind of back to the, or sorry,
Mhm.
you go.
I just wanted to bring in one point about advent of AI into jobs. So I think that's more pertinent for the younger folks who are coming into jobs in recent times. At least from the electronics or from our side of things, like the hardware side of things, we are seeing a lot more, let's say, need for automation, simply because there are companies that do things more efficiently with automation. So every company has to, or every person has to learn to code and work with automation in some form, maybe with or without AI. That's definitely need, even if you're not in computer science background. Given that, and in recent times, there has also been a push to for all teams to try to employ artificial intelligence or machine learning to further the automation and quality of work being produced. So that's kind of the nature of the future. Nature of the jobs of the future would be more on understanding how AI systems work and applying it to your specific field. So you don't have to be in computer science to do AI or coding.
Being an electrical engineer, how much coding or like using AI for coding do you have to do?
Um, it depends. So in, let's say, I haven't used AI so far, but for coding, there are a few things that I have had to do some coding for. In, let's say, 2 years of me being here at this company, I've probably done 3 months of coding, 4 months of coding. But there are things that I need to do once in a while that will make my job easier. Let's say I have two files that I have to somehow combine them in a specific way. I usually resort to some sort of a quick script to help me combine those files together. So there are some minor codes that uh, or knowing to write some small scripts does help. And I think ChatGPT makes life easier, but you still need to understand how the code works to debug it, because you cannot trust ChatGPT or any AI for that matter.
No, I've heard that you still have to know how to do it all ChatGPT and just make it faster.
Yeah, it does make things faster, especially on the coding side. Yes.
Yeah. Do you have any advice for someone who's still in high school or college who wants to be an electrical engineer?
Yeah, who wants to be electrical engineer? I would say keep your options open, but don't, as in, there are a lot of fields inside electrical that's not just about semiconductors. You have audio processing, you have RF design. There are a lot of fields, and uh, early in the career or early when you're in high school, try to get exposure to the different fields. There are a lot of resources on YouTube. It's good to just understand what happens. And early in the career, it's good to experiment with a lot of roles, like breadth of roles to know where your interest lies.
Do you think that people in college should, to some extent, prioritize doing more internships? Um,
Definitely. Yeah, I learned a lot of my signal analysis only from internship at Intel, because in Georgia Tech, in our group, there were no electrical faculty that could teach me those things. So I could either learn from some of the students, but there were not many there that could teach me the core of signal analysis. So the majority of it I learned from internships. So internships are you apply some aspects of what you learn, but you learn a lot more how the industry works and how efficiently things can be done. I think those are still not penetrated into the academia.
All right then. I think that was it. Thank you for meeting me.
Oh, thanks, Rohan, for the wonderful opportunity, and good luck to you on your endeavor. This is a great initiative, and I hope to see you reach great heights.
Thank you.